Hello, welcome back. This video is going to be very interesting and life related. So we've learned exponential function and the logarithm function. So how can we apply to the real world? So here's one example. In 2008, the population of Kenya was approximately 13.8 million and was growing by 2.684% each year, while the population of Sudan was approximately 41.3 million and growing 2.24% each year. If these trends continue, when will be the population of Kenya matches of Sudan? So what does the model look like? This is an exponential growth. So for exponential growth, we've learned the formula fx equals to initial value times 1 plus the growing rate, annual growing rate to the time. Okay, we can let both starting at 2008. So 2008, let's assume that would be the year 0. So that means the initial value of Kenya, the model of Kenya is going to look like with the initial value, what? 13.8 million times 1 plus the rate, the growing rate in Kenya is, we need to convert this to a decimal, which is 0.024264 to the time. And the population growth model in Sudan, if we're starting with 2008, the population would be 41.3 million plus the growing rate, which is 2.24 to the time. And they ask you, if this trend continues, when will be the population of Kenya matches that of Sudan? Match means when they were equal, they catch up with each other. So that means we want these two equations equals to each other and try to solve for t. So let me write this. This is very interesting because we're going to use lots of math knowledge that we've done before. Okay, what's your first approach? Well, I want to merge everything that's similar on the one side and the other thing with the other side, right? So because we're trying to solve t. So that means I'm trying to move everything related to t on one side. So what thing is related to t? Since t is the power of these parentheses, that means I want to move this part and this part on one side. That means I'm trying to get rid of the numbers. Well, how do we get rid of them? Since the parentheses and the number, they have a multiplication relationship. So that means I can divide it by either one. You can just move them on the left side or on the right side. They're the same. So let's divide it by 13.8 on one side. So now I have what? 1 plus 0.264 to the t equals to 41.3 over 13.8 times 1 plus whatever in the parentheses. Okay, the next thing is I would like to move this part to the right, to the left. Since they're multiplication relationship, so I want to divide them on both sides. So this is gone. So here's the equation. So remember the exponential property. If I have a over b to the t power, this is equivalent to what? This is equivalent to a to the t power over b to the t power, right? They can separate this one. On the other hand, that means they both have t power. I told you we're going to use lots of things that we learned before. That means I can merge these two together. So that means my parentheses is going to look like, my fraction is going to look like this. to the t power over 41.3 over 13.8. Alright, we can simplify the parentheses by calculate them, which is equals to 1.0264 over 1.0224 to the t power over this. This is just a number, so we don't need to worry about that. We don't need to try to simplify it because just a simple number. And now, something that we just learned this week. T, we want to solve t in an exponent. So we want to undo an exponent. So that means I want to convert this exponential into a logarithm. So my logarithm should look like this. Log, what would be the base? The base should be the complicated fraction. It looks scary, but the calculator will do the work for you. So this is going to be 1.0264 over 1.0224 to the top, because these two, they swap. The top is going to be 41.3 over 13.8 equals to t. Okay, so this looks complicated, so we still need to figure out t. How do you do it? Well, we know that these two are just a number. We can use a calculator to figure out what does this equal to and try to rewrite this. So now let me show you the calculator. In calculator, we have what? 41.3, divided by 13.8. So this is what? On the top is log 1.06443. And then in the bottom, I have 1.0264 divided by 1.0224, which is the base is going to 1.00391 equals to t. Okay, so remember how to do it on a calculator. In a calculator, you want to put it as a natural log or common log to divide them by what we learned about change of the base property. Then we will figure out t. So this is going to be what? Natural log 1.06443 divided by another natural log 1.00039. So this gives you the time, 16 years. Approximately, after 16 years, the population of Kenya will match the population of Sudan. So after 16 years will be what? Since the year we started with 2008, we add 16 years, this is going to be 2024. So that means by 2024, the population of Kenya matches the population of Sudan. So if we kept this, we use lots of knowledge that we learned before, such as how to solve an equation, and this part, I bet lots of you might be forget about this trick, and how can we use a calculator to calculate this part. So here is another example. A tank A contains 10 liters of water and 13.5% of the water evaporate each week. Tank B contains 13 liters of water and 50% of the water evaporates each week. In how many weeks these two tanks will contain the same amount of water? So we use the same trick. The first thing is we want to set up the equation. So this is an exponential decay. So the function is the same. Instead of 1 plus the rate, since it's decay, we use subtract to the t term. Okay, so for tank A, the model is going to be Fx. We're starting with 10 liters of water, and the decay rate is 13.5% to the time. And the tank B, they start with 13 liter, but it decays much faster, 50% each time, each week. So how many weeks will the tank contain the same amount of water? So pause the video and try to do it by yourself. It's the similar process. Well, we want them to have the same amount, so that means I want these two equations to be the same. All right, you can calculate everything inside the parenthesis first, since this is just one. So I have, oh, sorry. So that means I will have 10 times 0.65 to the t power equals to 13 times 0.5 to the t power. Again, we want to merge everything together. This is a multiplication. To break the multiplication, we need to use division, right? We divide by 13 on both sides. So I have 1/3 times 6.5 to the t equals to 0.5 to the t. And we merge these on the other side by dividing this part at the same time. So these are gone. So that I have 1/3 equals to what? Since they have the same exponent, we can merge this into a fraction. Now, in order to solve an exponential variable, we can use a logarithm function. What will be the base? This is the base, right? And then after the base, you can swap these two together. So I have the log. Base is 0.5 over 0.65 to 1/3 is the top, equals to our t. Now I'm just go ahead and use a calculator to calculate that. What does the calculator look like? You can, in the previous example, I use a natural log. This time I use a common log. We want to have a common log 1/3 over, a common log 0.5 over 0.65. This is equal to t. So now let's take a look. For a Google calculator, I will have natural log 1 divided by 3, which is our 1/3, divided by a common log 0.5 divided by 0.65. So this is 4.1a. So t is approximately 4 weeks. So that means after 4 weeks, this tank contains the same amount of water. All right, that's one of the application of our logarithm and exponential function. Next time we'll talk about half-life and double life, which is very interesting in a biofield. See you next time.